So if we now turn to the proton and the neutron that we used to think of as fundamental, i.e. can't be split up into anything smaller, we now understand that they are made of smaller particles still. So the Potent experiment was done very similar to the Rutherford scattering experiment, but this one's called deep inelastic scattering, where we fired electrons at very high speeds into protons. And by looking at the deflection of those electrons, then we found out that there's actually some structure within the proton itself. So the proton was no longer considered fundamental. And we now theorize that protons are made up of more fundamental particles called quarks. Sometimes pronounced quarks, sometimes pronounced quarks. Um, it's a kind of whimsical name that was made up, and nobody really knows exactly how to pronounce it. But I'll go with quarks. And we met 6 quarks in basically up, down, charm, strange, top, bottom, and that's them in their 3 families again. So similar to the leptons, then we can arrange these in families, and each of them has the corresponding antiquarks as well. Do these quarks have a charge? Well, the answer is yes. Okay, but they're charged with fractions of the electron charge. So, for instance, the up quark is plus 2/3 of an electron, down quark is minus 1/3, where E is the magnitude of the charge of an electron. But we have never actually measured less than 1 electronic charge at any one point in time. And the reason for this is that we never discover quarks on their own. We only ever discover them in combination with others. So they come in combinations, as far as we can tell, of 2 and 3. We've never discovered any other combinations. And they always combine in a way that their overall charge is an integer multiple of the electron charge. So it could be +1, -1, +2, -2, etc., or 0. So a proton that we're familiar with, it's got a charge of +1, and that's made up of 2 ups and 1 down quark, which adds up to +1 exactly. And the neutron has a charge of 0. That's because it comes from 1 up and 2 downs. And that gives you, once again, a total charge of 0. And incidentally, that's how you can have an anti-neutron. And you think, well, how can it be identical but have the same overall charge, but have the opposite charge if it doesn't have any charge, sorry? The answer is that it still has the same overall charge, but the quarks that make it up are the antiquarks with these up, down, down. So it would be anti-up, anti-down, anti-down. So when we group them together in sets of 3, then they're called baryons, and we group them up together in sets of 2, they're called mesons. And collectively, the particles that they make up, are called hadrons. Okay, so quarks are fundamental. A lot of names I know getting thrown at the same time. Quarks are fundamental, leptons are fundamental, and they form part of the standard model. But then we need to know these names when we group them together. That hadrons is what you get when you group quarks together, but they can be divided into baryons made of 3 quarks or antiquarks, and mesons. And basically that then explains this particle zoo. By combining these particles together in different combinations, then we can get the huge number of particles that were discovered, and they can all be explained.